In the last video, I looked at how comparables compare to method was implemented on integer and string, and I started implementing it on a new class I created called student. I finished that video having implemented comparable without a type parameter. In other words, I was using the raw version of comparable. Let's change that. I'll include the type parameter and set it to the current type student. Because of this change, my code doesn't compile anymore. I've got the error that the compare to method isn't implemented, but haven't I implemented it already? It was working in the last video after all. It's true that I do have a method called compare to, but now its signature doesn't match the one we need to match because it's not typed correctly. I need to re-implement this method, and I'll again use IntelliJ's features to automatically do that. Notice now that the argument in this method has a type of student, not an object. Now I'll replace the return 0 statement. I'll make this return name .compare2o.name. The only difference between these two methods is I don't have to cast in this one because the argument has the student type being passed in already. But I'm encountering another error which may be new to you. IntelliJ is telling us that both methods have the same erasure, yet neither overrides the other. This is a bit complicated, and I'll be talking about type erasure in detail in a later video. In summary though, this error means that Java at runtime can't figure out which method should get called, the one with object as an argument or the one with student. I'll move the entire compare to method defined with an object parameter below the other method of the same name, then comment it out. This will solve the type erasure problem for now. Finally, this class compiles, but in the main method, I've got a compiler error on that last line. This, as I've said before, is actually a good thing. Getting errors at compile time, I mean before we run the code. In this case, we don't really want to compare a string to a student object. I'll change that comparison to an instance of student instead, passing it my name all in caps. Let's see what happens when we run it. Firstly, you can see the array is sorted as before, so that's working. The last line, which compares student Tim with the name set to capital T and lowercase I and M to another student with Tim all in uppercase, gives us result equals 32. 32 is the difference between any uppercase letter and lowercase letter, as we saw earlier. I've spent a little extra time on this one interface to hopefully help you understand it as thoroughly as possible. Sorting and comparing instances of your own classes will be something that you'll be doing a lot. You will use comparable when something has a natural order, as we have seen here with student names. Natural order means that your object's compare to method will return a 0 if one object is considered equal to another, or the equals method returns true when the compare to method returns 0. If you had a list of students who could be uniquely identified by name, then this could be true. It's probably more likely that you'd have a student ID and use comparable's compare to method to sort by student ID, for example. Next, I want to review comparator, another interface for sorting and comparing, and talk about the differences between these two interfaces. The comparator interface is similar to the comparable interface, and the two can often be confused with each other. Its declaration and primary abstract method are shown here in comparison to comparable. Notice that the method names are different, compare versus compare to. The compare method takes two arguments versus one for compare to, meaning that it will compare the two arguments to one another and not one object to the instance itself. I'll review comparator in code, but in a slightly manufactured way. It's common practice to include a comparator as a nested class, which I'll talk more about in the next section of the course. I think it's valuable to talk about these interfaces together and when to choose or use one or the other, or both in your class. I want to get back to the student class and add a couple of fields. First, I'll add a couple of private static fields. I'm making them private because they're only needed inside student. The first field is last ID and set to the value 1000. The second is an instance of the random class. I'll add the instance fields student ID and GPA, which stands for grade point average, which is how well the student is doing overall. Notice that I've made GPA protected. I'll explain why in a minute. Next, I'll change the constructor and assign values to ID and GPA using these static fields. ID equals last ID, incremented by 1. Because last ID is a static, there's only one copy in memory. Any instance that increments it increments that one copy, meaning no two students should get the same ID, since we're keeping the last ID in a central place. GPA equals random.next double, and I want to pass the lower and upper range of the doubles I want back. A grade point average can be any value from 0 to 4. A 4.0 is an A, a 3.0 is a B, a 2.0 is a C, and so on. Next, I'll change the compare to method so that I'm comparing IDs, since this is the field that makes our student unique, and I'll sort by student ID as the natural sort. Since my ID field is a primitive int, I'll need to box those in wrappers to compare the IDs. I'll compare the ID field using integer dot value of. You may ask why I just didn't use an int calculation here, returning ID minus OID. It's less error prone to use Java's comparison of integers, so I'll just leverage the compare to method on integer. I want to print out all the fields in the toString method. I'll return a formatted string for ID, name and GPA. This will print out the student ID, student name, and their GPA with 2 decimal places. Let's run the code to check the results. The students are sorted by the assigned student ID, as you can see, lowest ID to highest. The result of comparing a new Tim student with the existing Tim student instance is a -1. This is because the first Tim's ID is always less than the new Tim's ID. Okay, so we've got a comparable and sortable student. But what if we want to sort by GPA to figure out who our best students are? We don't want to touch the compare to method. We could write our own sorting mechanism, but we don't have to. Instead, I'll create a class that implements comparator, comparing two students. I'll add this class above the student class in this file. Class student GPA comparator implements comparator of student. Public int compare with 2 student parameters. Return GPA plus name of the first student compared to GPA plus name of the second student. Okay, so I've got a class called student GPA comparator, and that implements comparator with a student type parameter. And I've implemented the compare method. To be technically correct, because I'm overriding the compare method, I'll add the override annotation above the method. I want to compare GPA scores, but if there's a tie, meaning 2 students have the same GPA, I'll sort alphabetically after that. Notice that I have a compile error, and that's because name is private on student. I hope by now you aren't very happy about making a field anything but private, but for this example I'll change it. In the next section, we're going to make this comparator class a nested type, but for now it's outside of the student class, and the only way it can access this field is if we make the name field protected or package private. I will make it package private, meaning I won't specify an access modifier at all. You can also make this protected, like I did for GPA. I wanted to show you that either way will work in your comparator class. The protected modifier would allow subtypes of student outside of the dev.lpa package to access the field as well, but really in this example I won't have a subtype, so I'll use this variation. That change means our custom comparator class compiles, but how do I use it? Well, it turns out the arrays.sort method has an overloaded version that takes a comparator as the second argument. I'll create a variable of this type in the main method, then call sort on my students using it. Comparator student called GPA sorter equals new student GPA comparator, arrays.sort passing students, and GPA sorter. And finally, I'll print out the array. Okay, so I've got a new instance of my comparator. Notice my reference type there, comparator with student in angle brackets. I could have used var for simplicity, but this is the explicit type. Next I call sort, passing it the GPA sorter. Note that sort method won't use the comparable compare to method. It will instead use this comparator's compare method when sorting. So that's pretty neat. Let me run this so we can see what happens. You can see my students are sorted by GPA lowest to highest, but that's not what I want. I want them to be sorted highest to lowest. How do we get that to work? I could change my comparator's compare method. Let me show you that. I'm going to swap O1 with O2 in that return statement, and running it this way. You can see I get my students by the GPA in descending order, but you don't really want to do this. You want this method to return things in order of lowest to highest, and we've reversed that. Let me revert that last change. The comparator interface, unlike comparable, comes with many other methods, most of them static helper methods, but with some default methods. Many of these are useful for streams, so I'll hold off on discussing them until that section. but one of them is very convenient for what I want to do here, and that's the reverse default method. I can call that on the GPA sorter as I pass it to the arrays.sort method in the main method. Let's see what that gives us. I get my students in reverse GPA order. Let me summarise the differences between these interfaces. Comparables method is compare to and takes a single argument that will get compared to the current instance. Comparators method is compare and takes two arguments of the same type to be compared to each other. Comparables compare to method is called from an instance that implements comparable. Comparators compare method compares objects that don't require them to implement comparator. Arrays.sort with a single argument requires the array elements to implement comparable. Arrays.sort with two arguments does not require the array elements to implement comparable, but will use the comparator pass to sort the elements. It's considered best practice for a natural order sort if comparables method returns 0 when the instances equals method is true for the same argument passed. Comparator allows for a variety of different ways to sort objects. I'll be revisiting comparator in our nested types discussion, and you'll have plenty of opportunity to use both when we explore more of Java's collection types. Okay, so in the next video, I want to review a few more advanced topics on generic classes and methods. See you in the next video.